Okay, so in this video, we will be discussing the stack data structure. So first we'll look at the array representation of stack. Remember, there are two ways in which you can represent a stack. One is using arrays and the other is using linked list. So first we'll look at the array representation of stack. Now see, what is an array? An array is a linear data structure. What do you mean by linear data structure? A linear data structure is a data structure in which the elements are arranged in a straight line fashion. That means one element will follow another element. Like you see in arrays in linked lists where elements are followed one after the other, even in stack, elements appear one after the other. Remember, a stack follows last in first out algorithm. That means the element which is inserted last in my stack will be the first to be pulled out. The element that goes in last is the first one to be pulled out. That means the element which goes in first is the last one to be pulled out. And all operations, remember, the operations that we'll see just now, insertion, deletion, all these operations take place at one end of the stack only. It takes place at the top of the stack. Remember, the insertion operation has a special name in stack. It is called push. The element that you want to insert into the stack is denoted by item. If you are looking to delete an element from the stack, you would go for a pop operation, where the element which is at the top of the stack is the first one to be removed. For example, if you have a stack of plates, the last plate which you had put on the pile will be the first one to be removed. Same is the case with stack. And there is a third operation known as peek. Peek will help you to find the topmost element of the stack. Let's look at point number 7. Now, point number 7 says that the size will denote the maximum number of elements that are possible in a stack. Remember, you are storing elements. That means you are dealing with memory, and memory is finite. As a result, stack, like other data structures, is a finite data structure. So the size of the stack will be limited. As a result, we will have a special variable called size, which will denote the maximum number of elements that we can store in a stack at a single point in time. And we will be making use of a top of stack pointer to carry out all operations. In array implementation of stack, TOS will be a integer variable which is initially given a value of -1. The question is, why give it a value of -1? See, TOS in array implementation of stack will get a value which is 1 less than the smallest index of the array. What is the smallest index of the array? The smallest index of the array is 0. And what is 1 less than 0? 1 less than 0 is -1. As a result, TOS initially gets a value of -1. And like I mentioned right at the outset, that it is implemented, stack is implemented using arrays and linked lists. And what are some of the applications of stack? Stack is used in recursion as well as infix to postfix evaluation. There are other applications as well, like postfix evaluation, infix to prefix conversion, and many more. Now see, here we define the two operations, push and pop. So if you want to push an item onto the stack, it will involve two steps. First, you will have to increment your TOS, which is denoted by top here. You have to increment your top by 1. And next, what you have to do is you have to insert the item at the position which is denoted by the value of top. That means if top becomes, let's say, after incrementing the value of top, you get 3. So the item will be inserted at position 3 of the array. Even pop operation involves two steps. Here, the first step is you will have to remove an element from the position which is currently denoted by the value of top. So let's say the value of top is 3. So you will have to first remove the element which is present at position 3. And next you have to decrement the value of top by 1. And remember, before pushing an item onto the stack, you will have to check whether the stack is full or not. And if stack is full, we will be printing a statement, stack overflow. And similarly, even before a pop operation, you will have to check if the stack is empty or not, because it is not possible to remove any element from an empty stack. If the stack does not contain anything, how will you remove an element? So if the stack is empty, we will have to print stack underflow. Now here we'll take an example. You can pause the video and copy down this question. I have a stack which is called S and it has a size of 3. We will have to show the content of the stack at each step for the following sequence of operations. So let's see what happens. So step number 1, as you can see, the first step is a pop operation. So if I want to carry out a pop on an empty stack, obviously I have nothing to delete. Pop operation means remove an element from the stack, but initially the stack does not contain anything, and that is denoted by a value of -1 for TOS. So if the stack does not contain anything, we will have to print the statement stack underflow. Step 2 is a push operation, and what do you want to push? You want to push 3. As you can see, within parentheses you have the value 3. That means 3 denotes your item. Now since TOS is -1, the stack has empty space, so we can insert our item onto the stack. So it involved 2 steps. If you remember, which was the first step? See, here push involves 2 steps. Step number 1 is you have to increment top by 1. So that is what I'm doing. So from -1, your TOS changes to 0. And after it changes to 0, what will you do? You'll have to insert your item at position, which is denoted by the value of top. So what is the current value of top? The current value of top has changed from -1 to 0. So you will insert your item, which in this case is 3, at position 0. Now next step is you have to push 7. So it's the same thing. You will first increment your top by 1. So your TOS was 0 after step 2. So you will first increment your TOS by 1. So TOS becomes 1, and you will insert your item, which is 7, at this index 1 position. Next is another pop operation. Now see, since TOS is not equal to -1, it means that the stack has elements in it. See, only if the top of stack contains a value of -1, you will have to understand that the stack is empty. But since here, in this case, top of stack is initially 1, it means that the stack has elements. So we can remove an element from the stack. So how will we remove an element? We will first, or let's say, how will we pop an element from the stack? We will pop an element by first removing the element at position 1. See, what was the current value of TOS after step 3? After step 3, the value of TOS was 1. So we'll first remove the element which is present at 1. You can see that the element which is present at position 1 is 7. So we'll first remove it. And after removing that element, we will change the value of TOS from 1 to 0. Step number 5 is you have to push 12. So again, the stack has space, has empty space. So we'll first increment the value of TOS by 1. So TOS changes from 0 to 1. And then we will insert 12 into that position. That means the position denoted by the value of TOS. And the value of TOS is currently 1. So we'll insert 12 at position 1 of the array, which is nothing but your stack, because here we are implementing the stack as an array. Now step number 6 is another push operation where you have to insert 19. So again, you will first increment the value of TOS by 1. So TOS changes from 1 to 2. And then you will insert your item, which in this case is 19, at the position denoted by TOS. So TOS currently has a value of 2. So you will insert 19 at position 2. Now step number 7. See, again, it's another push operation. But as we can see that the stack is full. And how can you check this? Using a programming statement, you will check this with the value of size -1. So if your top of stack value is same as the value of size -1, that means the stack has no empty space. And if the stack has no empty space, you cannot push any more elements. As a result, this operation, step 7, push 23, will not go ahead. You will not be able to insert 23. Instead, you will get an error, which is stack overflow. See, what is the size of the stack? The size of the stack is 3, right? And since your array indexing starts from 0, you will be checking with size -1. So if your top of stack, which in this case is 2, if it is same as size -1, it means that the stack is full. And the last operation, which is peak. So peak 23. In fact, what will happen is, in case of peak, you will not be specifying the value. I have made a slight mistake here. See, this 23 will not be there, okay? You will simply write peak. This 23 will not be there. What peak does is, it simply displays the topmost element of the stack, whose position is denoted by the value of TOS. What is the current value of TOS? The current value of TOS is 2. So the element which is present at 2 is 19. So you will simply display the element at index 2, because 2 happens to be the value of TOS. Since 2 happens to be the value of TOS, you will display the element at index 2. Here 23 will not be there. You simply specify the peak operation without passing any argument to it. This is a mistake on my part. Next, we'll look at the linked representation of stack. So it's the same question. So again, the first operation is pop. Now see, in a linked representation of stack, what happens is initially my top of stack will be null. Why? Because my stack is empty. So in order to understand an empty stack, the TOS will be set to null. Now since the top of stack is null, there are no elements in the stack. So we cannot go ahead with the deletion operation, and we'll simply print a statement stack underflow. Now step number 2. Now this is interesting. Initially my stack was empty. Now I want to push this item. So what will I do? I'll first create a node. And after creating this node, what will I do? I will insert 3, which is my item, in its data part, and I'll insert null in the link part. Why? Because right now my stack, which is implemented as a linked list, contains exactly one node, and we know that from our previous videos that a linked list containing exactly one element is the first node as well as the last node. Now since it happens to be the last node, its link part has to be null, because we know that the link part of the last node of a linked list is always null. So we have to set this to null. And what is this 100? This 100 is the address of this memory block. This entire memory block is made up of multiple bytes. Now 100 denotes the address of the first byte, and since TOS here is a pointer which is pointing to this node, 100 will be stored in it. Since 100 is stored inside TOS, it is as if TOS is pointing to this memory block. Now look at step number 3. We'll have to push 7. So how do we push 7? We'll push 7 by inserting 7 at the beginning of the stack. See, all my elements will be inserted at one end. I am assuming that the elements are inserted at the beginning of the linked list, which in this case is my stack. So if I insert an element at the beginning, so 7 will be inserted here. So this is same as inserting an element at the beginning of the list. So you can make a point here, that you can make a note rather, that the push operation can be implemented using insert begin operation of linked list. So if you implement the insert begin operation of a single linked list, you will in effect be implementing the push operation for a stack which is implemented as a linked list. Okay. Next is we'll have to pop. So which element will be pop? We'll pop the element which is pointed to by TOS. See, TOS points to this element. So this is my top of stack. So if I want to pop an element, I'll have to remove 7. So that's why 7 is removed, and as a result you're left with only 3. Now what is this pop operation? See, I am removing an element from the beginning of the list. So just like I saw that pushing an element is same as inserting an element at the beginning of a linked list, popping an element is same as deleting an element from the beginning of the linked list. Now look at step number 5. Step number 5 is another push operation, which is 12. Again, I'll insert an element at the beginning of the linked list. So TOS is pointing to this node, my newly inserted node. And next is 19. So you can see here was 12, here was 3. Now 19 should appear before 12. See, that's what happens. 19 appears before 12, and these addresses these values denote the addresses of these memory blocks. Now step number 7 is push 23, but like we started off the stack with a size of 3, since the size of the stack is 3, like I mentioned right at the beginning, I cannot insert more than 3 elements in my stack, in my linked list. As a result, I'll get a message saying that my stack is full, that is, there is a stack overflow condition. And the last thing is peak. As you can see, nothing has been specified here. So peak means I want to simply display the data part of the node which is pointed to by TOS. So TOS is pointing to this node. Now 19 is the data part of the node, so I'll simply display 19. Now let's look at a few questions which have been asked in your previous years. The first question is, what is a stack? And you have to explain the various operations performed using stack with examples. So what are the various operations that are performed using stack? The various operations that are performed are push, pop, and peek. And what about the definition of stack? So stack is a linear data structure which follows the last in first out algorithm. So you can find the answers in these points. Okay, so you can find points 1 and 2 in slide 2, which would make up your stack definition. Entire slide 3 and point 6 of slide, this will be slide 4. Okay, this will be entire slide 3 and point 6 of slide 4. This will constitute your operations, and slides 4 to 12 will give you the example of stack operations. And what about the next question again? What is stack? So it's the same. It's a linear data structure following last in first out algorithm. And the example is the same which I explained. See, this is the example. I'll point out. So you give this example, you show the sequence of steps 1, 2, 3, 4, 5, 6, 7, 8. These 8 steps will take care of this example. So that will answer your question. And here, what is stack is points 1 and 2 in slide 2. So if I go to slide, this is my slide number. Okay, this is 14, 13, 12, 9. You can see it down here. This is my slide number. So here at slide 2, you will find points 1 and 2. So linear data structure and follows the last in first out algorithm. And also, in the first question, if I look at the first question, the first question here, they explain various operations. So entire slide 3 and point 6 of this should be, I'm showing you, okay. So entire slide 3 will be taken. So let's see. So this entire slide, okay, you'll have to include this entire slide in your operations, and you'll have to include point number 6 of slide 2. So that will be slide 2. You'll have to include 3 operations: push, pop, and peek. So you'll get push and pop in details here, and you will get peek here at point number 6 of slide 2. So this will be not slide point 6 of slide 2. Okay, just make this correction. This will be point 6 of slide 2. And now you have been asked to write C functions to implement push and pop operations. So what I'll do is I'll write some live code and make you understand the operations of stack using array. See, they have not mentioned about an array or linked list. They have not mentioned anything about that. So I am assuming that I can use any of the data structures. I can either use an array or I can use a linked list. I'll go ahead with the array implementation of stack. Okay, so let's see how we can use an array to implement the push and pop operation. So the steps that I discussed in theory will now be put into practice. So let's see how we can implement a stack. Okay, so I'll be writing the entire code. Okay, so first I'll be importing the standard input output header file, and now I need to write 2 functions, right? I need to write a push function. So I'll write a push function, and this push function, it will accept. I'm building a stack of integers. You can also have a stack of characters or a stack of floating point values. All that is allowed. Here I'm assuming that I have a stack of integers. So first I am declaring this function. This is my declaration. This is the declaration of the function, and I need another function which is pop. So this is my pop function. Again, this is another function declaration. So this is how you declare a function, right? Sorry about that. This is the function declaration for pop, and I need the peek function as well. So I've declared 3 functions. You can understand. Now what I'll do is I'll take the stack as an array, right? Now before going for the stack as an array, I need to define the maximum number of elements that can be accommodated in a stack. How do I do that? I say hash define size. Let's say I take a size of 3. You can take any value. You can take 300, you can take 3000, you can take 30. Here, just for simplicity, I'm taking 3. So now I'll define my stack. I'm implementing my stack as an array, and I'm defining the array in this case to be a global variable. Okay, so the name of my stack is st, and its size is same as this symbolic constant. This symbolic constant size, this goes here. Okay, so when I write size, it means the value of 3 will be substituted. The value of 3, see, this size, this is a symbolic constant which will be substituted by the value of 3. Okay, and I also need my top of stack variable. So initially top of stack will be -1, and now I want to implement the push operation. So the push operation, now before implementing, let's do one thing. Let's define the main first, and then we'll implement our own function. So let's write the main. Now what I'll do is I'll implement a menu driven program. So for menu driven program, it's always advisable if you can come up with a do while loop. So I'll first print out the menu, right? So I'll print out the menu. So what are my options? I'll ask the user to either push, or I'll ask the user to pop, or I'll ask the user to peek. Okay, so this is what it is. And now I'll also have another operation or another option for exiting the menu. And now what I'll say is I'll ask the user for his or her choice. So I'll say, you please enter your choice. After seeing the menu, the user will be asked to enter the choice. Now I'll have to store this choice that the user enters, right? Seeing this statement, the user will enter a value. I'll have to store that value inside a variable. So let me use a variable called choice to store the choice which is entered by the user. So I have to declare a variable. Let's say choice. Now what I'll do is I'll accept the choice from the user. Now depending on this choice, I'll run a switch. So I'll say switch. Now what are the possible cases? Case number one is when the user wants to push. So if the user wants to push an item, then I have to first know the value of the item. So I'll ask the user to enter the item to be pushed. Now seeing this statement, what will the user do? The user will enter a value and I'll have to store that value inside a variable. Let's call that variable item. Okay, so I'll have to declare another variable called item. Now after storing this, what will I do? I'll push the element. Now in order to push the element, I have already written a function. I have not defined it yet, but I have a function which I'll be defining later on called push. So I'll be calling this function. So I'll simply call this function and pass the value of item. And after I'm done, I'll break out of the case and move on to the next case. So the next case will be case 2. Now case 2 means, as you can see, what is choice 2? Choice 2 is pop. So if the user enters a choice of 2, so the user enters a choice of 2, I'm assuming that the user wants to pop an item from the stack. So what will I do? I don't have to display anything as such, right? I can directly call the pop function because the pop function will not be expecting any arguments. As you can see, I've declared this function and even I've explained in my PowerPoint presentation that pop will not accept any argument. You simply call the function and it will remove the topmost element. And after carrying out the pop operation, I will simply break out and move on to the next case. So what is case 3? Case 3 denotes the operation if the user enters choices 3. So I'll simply call the peek function. So after calling the peek function, I'll break. And what is case 4? Case 4 is my exit option. So I'll simply display a message for the user that, okay, thank you for visiting my program. So I'll say goodbye. And what if the user does not enter any of these 4 choices? See, what are the choices I'm offering to the user? I'm offering choice 1 for push, choice 2 for pop, choice 3 for peek, choice 4 for exiting from the program. But what if the user enters anything outside 1, 2, 3, and 4? Then I should take care of that situation as well. So I should have a default clause that anything which is not 1, 2, 3, or 4 will amount to an invalid input. So I should say invalid choice, try again. So I'll give the user another opportunity to enter a valid choice. Now after all this, what will I do? I'll close off my while. So till what time will this entire loop run? This entire loop will run till the time the user wants to. And when will the user not want to run this loop? When the user enters a choice of 4. So the condition here for while will be while choice is not equal to 4. That means till the time the user does not enter 4. That means if the user does not want to exit. See, 4 denotes exit. So till the time choice is not equal to 4, this loop will keep on running. So I hope you have understood this part. See, my option 4 denotes exit. If the user wants to exit, the user will enter choice as 4. So where will it go? It will go to case 4 and it will print goodbye. And then here in the while condition, what will it check? While choice is not equal to 4. But what is the value of choice? The value of choice is 4. That's why this case 4 statement was executed. So this condition will not be satisfied and I'll come out of my loop. So that is why we have used a do while loop. It's easier to handle menu driven programs. Now after doing all this, what will I do? I'll simply end off my main function. So I'll say return 0. Now after I'm done with my main, I'll have to define my user defined functions. So I have declared 2 functions, in fact 3 functions of my own. One is push, the other is pop, and the third one is peek. So what will I do? Before pushing. Remember from the slides, I had mentioned that before pushing an item onto the stack, you'll have to check whether the stack is full or not. And how do you do that? If your TOS happens to be same as size minus 1, then you will simply print a statement. You will print a statement that the stack is full. That means stack overflow. But if this condition is not satisfied, what if this condition is not satisfied? If this condition is not satisfied, I'll come to the else part, and in the else part, I'll insert an element on my stack. I'll push an element on my stack. So how will I push? Step number 1 is I'll increment the value of TOS by 1. And next, what will I do? What was the name of my stack? If you remember the name of the array here is ST. So I'll increment the value of TOS by 1. See, I've incremented the value of TOS by 1, and then at the value or at the position denoted by TOS, how do I access the value, or how do I access the position which is denoted by the current value of TOS? I say ST of TOS. This is the array indexing operator. So I want to index, or I want to access the value which is currently denoted by TOS. So I'll do that, and what will I do? I'll simply insert my item at that position. So after I'm done with push, I'll go for the pop. So pop does not take in any parameter. So first thing that I need to check is whether my stack is empty or not. So how do I do that? I'll simply check whether TOS is minus 1. If my top of stack happens to be minus 1, that means the stack does not contain any element. If the stack does not contain any element, then I cannot remove anything from it. So I need to display a statement stack underflow. And next, if the stack happens to contain elements, I have to remove an element from it. So what will I do is I'll decrement the value of TOS by 1, but before decrementing, I'll simply display the element which I have removed. So which element am I removing? So I'll say pop element is your %d. So in place of %d, I'll substitute the element at TOS position. So how do I access the element at TOS position? I say ST of TOS. So this will give me the popped element at TOS position. Now after removing this element, I'll simply decrement the value of TOS by 1. And finally, I have the peek operation. So peek will simply display the topmost element of the stack. And how do I get the topmost element of the stack? I get the topmost element of the stack by accessing the value of TOS. Now before peeking from the stack, I need to check whether the stack is empty or not, because if the stack is empty, there is nothing to look at. So if the stack happens to be empty, I'll simply print a statement. Now here I'll say stack is empty. I'll not say stack underflow. Purposely, I'll not use this phrase. I'll not use this phrase stack underflow for the peek operation, because stack underflow will be used only for pop. If any other operation requires this condition to be checked and requires reporting of the fact that the stack is empty or the stack is full, then I'll not use overflow or underflow. I'll reserve the statements stack overflow for push operation, and I'll reserve the statement stack underflow for pop operation. And if the stack does not happen to be empty, what will I do? I'll simply print the topmost element. So I'll say that topmost element of stack is %d, and in place of %d, I'll simply access the element at TOS position. So after I'm done with all these operations, let me try to execute this program. So let me just turn on my logs so I can see if I get any errors. Where is the problem? Will I get any errors? Let's see. I have my fingers crossed. Let's see if I get any errors. No, I don't have any errors. I don't have any errors in my stack. I don't have any errors in my program. Don't have any errors in my program. Now let me execute this. It's still compiling. Okay, now I have the menu with me. So it's going to take some time. Let's just wait up. Okay, now I have, okay, now there is some problem with the formatting. So let me just change the formatting here. Let me see my menu. Where have I gone wrong? So here I can see that there is a backslash n 1 dot push backslash n 2 dot pop backslash n 3 dot peak. Oh, I missed the n here. So that's why I got an error. I didn't get an error, but the formatting was out of place. So let me rerun this program after making the changes. See, it's normal to get errors, okay? Especially when you're coding live. It's normal to get errors. So, and it's a good thing. The more errors you get, the more errors you correct, the better for you. Now let's see. Let's try to execute this program. So it's coming. The menu is going to show up anytime. Let's be patient. Okay, it's there. Now let's say first I try to I'll test all possible situations. Let me enter an invalid input. What would be an invalid input? Anything which is not 1, 2, 3, or 4 is considered an invalid input, like I pointed out. Let's say I enter 76. What will happen? Okay, now my program is hanging. Okay, now this is interesting. Okay, now there's a problem here. So it's not working if I enter an invalid choice. Okay, now the problem here is I missed the break here. So there'll be a break. That's one thing. And the other thing is printf invalid choice. Try again. That's my default case. Probably because of this break which was missing. This break which I missed, there was an error. Let's try it again. Let's try to execute this program again. So it's compiling. Okay. Okay, now let's try the same input. Let's try 76. Now for some reason it's not working. Let me have a look. Okay, let me have a look. Okay, so let's try it one more time. Let's say I enter 56. Okay, yeah, now it's working. I missed an ampersand in a scanf, and that's why the program was crashing every time. I guess we are good to go now. Now, as you can see, I've entered a choice of 56, which is outside the valid choices of 1, 2, 3, and 4. So I get the exact statement which I was supposed to get. Now let's try a proper operation. Let's say I want to remove an element. Currently my stack does not contain anything. Let's say I entered 3. Let's say I want to peek. Okay, stack is empty. So this is working fine. Let's say I want to pop. Stack underflow. Since the stack is empty, I haven't pushed anything, as you can see. I haven't pushed any item. So currently my stack should be empty. And as a result, there's nothing to peek. There's nothing to peek. That's why I got this statement. Stack is empty. And there is nothing to pop. That's why I got the statement stack underflow. Now let's say I want to push an item onto the stack. So I say 1. It's asking me for the item that I want to push. So I say 23. Okay. Now let's say I want to push another item. So I go for another choice of 1. Let's say I want to push 12. Okay. So 12 is currently my topmost element. Let's see if 12 is my topmost element. Let's do a peek operation. Yes, the topmost element of the stack is 12, which should be the case because see, this is the latest item to be pushed. 12 was the latest item to be pushed. So if I want to peek, 12 should be my topmost element. So it's good. Now let's say I want to do another push operation. So let's say I want to push 77. Okay. Now if I want to carry out a peek operation, yes, 77 is the latest element to be pushed. So it is done properly. 77 has been pushed properly. Now what if I want to push another element? Will I be allowed to? It's asking me for the item, but no, it's stack overflow. See, if you remember, I have defined my stack to be of size 3. That means this stack can accommodate a maximum of 3 elements. I have already carried out 3 push operations. As you can see, this is the first push operation. In fact, sorry about that. I need to go up a bit. Yeah. So this was the first, where is the first push operation? Let me scroll down a bit. Yeah, so this was the first item to be pushed, 23. Then 12 was the next item to be pushed. So that's 2 items. Then 77 was the third item to be pushed. Now I already have pushed 3 items onto my stack. Can I push another one? I cannot because I've defined the size. As you can see, I've defined the size to be 3. So that's why I get an error of stack overflow. Now, what if I want to pop? So I say 2. Now the popped element is 77. So if the popped element is 77, so before 77, which element was there on my stack? I had 12. See, before 77, I had inserted 12. See, Before entered the item to be pushed was 77. Before pushing 77, I had pushed 12. That means after removing 77, what should be my topmost element? My topmost element should be 12. So let's do a peek. Yes, I'm getting 12. That means this program is working fine. So I hope you have understood this. Now let's move on to the questions that we were discussing. So this was one of the questions. Now let's move on to another one. Okay. Now the next question is, you have been asked to write algorithms to implement push and pop operations in stack. Okay, before going on to this question, let's come back to this. So the question was, you have to write C function to implement push and pop operations of your stack. And this was asked in 2016. Now see, they've asked for C functions. So would you write the entire program? You will not be writing the entire program, mind you. You will not be writing the entire program. You will be only writing the push and pop functions. See, I wrote the entire program so that I can show you the execution process and how the stack actually works. But in this question, you have been asked only to write C functions to implement push and pop operations. You have been asked to implement only push and pop operations. So you can only write those two portions. I'll tell you which parts to write. I'll tell you. Just give me a moment. So for examination purpose, how much would you write? You would write two functions. First of all, you'll start with this part. You will start with these two lines. These two lines will be your starting portion of the program, or let's say starting portion of the solution, because you have not been asked to write the entire program. So after writing those two statements, you will move on to this part. You will be defining the function, and then you will be defining this function as well. That's it. This will be the answer to your question. Let me show you the complete thing. Okay, so let me just copy this. Let me create a new file where you can see the exact solution. Now see, let me just close this. Yeah. So this is the entire solution. Okay, I think I missed the first two lines. Yeah, I think I missed the first two lines. Let me bring the first two lines as well. These are the two lines that you'll be starting your answer with. You'll be starting your answer with these two lines. Okay. So this is the complete answer to the question. You will start off with these two lines, and I think it's better if you include one more line. If you write this hash define, let's say size, you can take any value for size. Let's say you take 10. 10 is a standard value. So you start with this line hash define size 10, and then you write these two, and then you move on to write your functions. Okay, so this will be one function for push, and this will be another function for pop. So that will be the complete answer to the question. Okay, now let's move on to the next question. Now look at this. The next question is, you have to write algorithms to implement the push and pop operations in stack. Previously you were asked to write functions, right? You were asked to write C functions. Now you have been asked to write algorithms. So this is the algorithm. So algorithm is independent of any language, as you know. So this would be the complete answer to the question. Okay, don't worry, I'll be sharing this entire PPT with you. That it will be given in the comment section as well as the description section of the video, so you can have a look. So this is what it is. See, first you'll be writing the push algorithm. So you will first define your input, your output, and the data structure that you're using. You're using an array, so that's why I've written an array A with top as the pointer. So you'll write your steps. So you'll start. You'll first be checking whether your top is greater than or equal to size or not. If that happens to be the case, see, here I've written greater than or equal to size. You could also write the one which I've written in the program. But since your algorithms should be programming language independent, it's better if you write this. Okay, if top is greater than or equal to size. So if that happens to be the case, you'll print stack is full. Here you can make one correction. Instead of writing stack is full, you can write stack overflow. And in the else part, if the stack does not happen to be full, you'll simply increment your top by 1, and then you'll insert an item at the topmost position. So you'll end your if and you will stop the algorithm. Now in algorithm pop, what will you do? You'll first check whether top is less than 1. So if top happens to be less than 1, then you'll print that the stack is empty, because it may happen that in some programming languages your arrays begin with index 1. So if your arrays begin with index 1, then what should be the initial value of TOS or initial value of top? See, top and TOS, they're used synonymously. TOS stands for top of stack, and top also denotes the top of stack. So in some books or in some, let's say in some papers, you would find the use of TOS, and in others you would find the use of top. So here in my algorithm I've used top, whereas in my program I've used TOS. you can use any one that you want. Now here, so what was I saying? I was saying that if a programming language has arrays where the indexing starts from 1, then what would you do? You would always have your TOS or your top to begin from 0, because what is the rule for initializing the value of top? The rule is it should be 1 less than the lowest index of the array. So in this case, the lowest index is 1. So top should start from 0. If your lowest index is 0, then top should start from -1. If your lowest index is -1, then your top should start from -2. So it is dependent on the programming language. Now, in order to write an algorithm which is, let's say, independent of most popular programming languages, I've used top less than 1. So if top happens to be less than 1, that means the stack is empty. You have nothing to delete, so the pop operation will not take place. Now here I've said print stack is empty. Again, you can make one correction here. Instead of saying stack is empty, you can say stack underflow. And if the stack is not empty, then you simply access the topmost element of the stack, store it in item, and decrement the value of top by 1. Okay, so item will contain the topmost element which you have just popped. So here I have used item to store the popped element. Okay, and in my program what I did was I displayed the topmost element. You can follow either approach, so that won't be a problem. And what about the last question? Last question that we have to discuss is, in fact, the second last question. We have one more question to discuss. So the question is, what are underflow and overflow conditions? We saw just now that if we try to insert more elements in a stack than it can accommodate, then it is a case of overflow. And we use the technical term stack overflow to denote this condition. And if we try to remove an element from an empty data structure, then we say that it is a case of underflow. So here we have discussed stack, so you can take the example of stack underflow. Even for a data structure like queue, if you try to insert more elements than its length, then you will get an error, or let's say you will not get an error, you will get a message saying that the queue is full. Similarly, if you try to remove an element from an empty queue, it amounts to an underflow condition, and you will get a statement saying that the queue is empty. Okay, so this is what you mean by overflow and underflow conditions. And see, they have asked you to write a short note on the linked representation of stack. So in order to answer this question, you can obviously take up the example which I showed you. So I'll tell you which one, the example that I'm talking about. I'm talking about, yeah, this example. You can definitely give this example. This will serve good purpose. And along with that, you can just write a few points, like you can write points like, that every element is stored in a node of a linked list. The push, let me write operation here. The push operation is same as inserting an element at beginning of linked list. The pop operation is same as deleting an element from the beginning of a linked list. So this should be enough. It carries only 3 marks. Giving that example and writing these few points should serve your purpose. So I hope you have understood a lot about stack. If you have any doubts, please feel free to comment in the section given below. Thank you for watching.